Hello, I am Dr. Chukwuzubelu Ufodike, PI and Director of the Digital Manufacturing and Distribution Lab here at Texas A&M Engineering Experiment Station, TEAS. At the DMD-Lab, our mission is simple. We are reimagining how products are made, measured, and moved. Our research sits at the intersection of advanced manufacturing, data science, and digital distribution. We bring together people, machines, and materials in smarter and more connected ways. As I reflect on why this work matters to me, it really goes back into where my journey in engineering began. My journey into engineering began with a deep fascination of how things are designed, built, and improved to solve real problems. I've always been drawn to practical side of science where ideas turn into tangible solutions that help people and communities. That curiosity led me to study industrial and manufacturing engineering, and over time I expanded my work to include computational design, material science, and digital manufacturing. I chose Texas A&M University because it is a place where research, innovation, and impact intersect in powerful ways. Here we do not just study technology, we shape it, scale it, and apply it to real challenges. This is what drives my work every day at the DMD-Lab, building meaningful solutions with students and collaborators who share this vision. That journey is what inspires the research we do in the lab every single day. First, we develop AI-enhanced additive manufacturing systems. These are 3D processes that can sense their environment, learn from data, and make real-time adjustments to improve quality and reduce waste. Second, we study smart manufacturing and process systems. In these systems, sensors and digital models work together to make factories more efficient, reliable, and adaptive. Third, we apply data analytics to distribution and logistics supply chain. This helps companies make better decisions about inventory, transportation, and supply chain performance. Finally, we focus on testing and measurement. Here we link simulation with physical experiments to ensure that the models we build match real-world behavior. Everything we do is guided by a tight feedback loop between digital simulation and hands-on experimentation. We build high-fidelity models, validate them through instrumented experiments, and use what we learn to design better systems for the next generation of manufacturing. Let's take a closer look at how we approach these challenges and why our work stands out. What makes our lab truly special is the way we connect science and practice. We do not just study problems, we replicate them. We measure them, we solve them through rigorous engineering and creative thinking. Across manufacturing, for example, and distribution, one challenge remains constant. How do we do more with less and do it faster? Our work addresses these challenges in a practical way. Closed-loop additive manufacturing helps reduce turn-in time, for example, and material waste. Smart sensing, for example, which is smart sensing and control, would prevent downtime before it happens. Digital analytics make supply chains more agile and responsive. When these improvements come together, they create resilient systems. These are systems that keep performing even when conditions change. To make all this possible, we rely on advanced tools and a talented team working at cutting edge of manufacturing research. Our research is powered by advanced tools and a team of talented researchers at every level. This includes postdoctoral fellows, Ph.D. and master's students, undergraduate researchers who work side by side to push the boundaries of digital manufacturing. In terms of equipment, we use rotational rheometers to study how materials flow under heat and stress. This helps us understand and control 3D printing behavior, for example. Our capillary rheometer allows us to simulate real extrusion and molding conditions for polymers and composites. FTI aerospectrometer would help us analyze material chemistry, identify contaminant, for example, and verify molecular composition. For imaging, our confocal microscope captures materials in extraordinary detail. It reveals how microstructure evolved during processing, and our 3D printing capabilities, which we do using 3D printers. We can prototype everything from basic polymers to advanced flexible composites. Together, these tools would help us connect material behavior, process control, product performance, and this will create a strong foundation for predictive and intelligent manufacturing. But this work is about more than tools and experiment. It's about the impact we create for people, industries, and communities. Our goal is not only to advance technology, but also to shape a more sustainable, human-centered future for manufacturing. In the DMD-Lab, innovation is about more than machines. It's about people learning to design systems that are efficient, resilient, and adaptable. We prepare our students to lead in this new industrial landscape. Their research touches many areas, including aerospace, healthcare, and logistics. Every model we build, every dataset we analyze, and every prototype we print contributes to a shared vision. That vision is a world where intelligent manufacturing strengthens communities and industries and economies. And that brings me to what truly drives our lab forward. It is the vision of shaping the future of manufacturing through innovation and collaboration. Every day in the DMD-Lab, we transform ideas into measurable impact. We are training the next generation of engineers and researchers, from postdocs to undergraduates, to think critically, work collaboratively, and innovate responsibly. I am Dr. Chukwuzubelu Ufodike, and this is the Digital Manufacturing and Distribution Lab at Texas A&M University. This is where research meets real-world impact, one intelligent process at a time.